Let me start our discussion on this review of basic laws. For any electrical engineer, there are three basic laws available: Ohm's law, Kirchhoff's current law, and Kirchhoff's voltage law. So in this particular lecture, we will review the basic law of electrical engineering, right? So the first law is on the Ohm's law. So Ohm's law states that at constant temperature, the current through the conductor is proportional to the voltage. So this particular word is very important. At constant temperature is very, very important to understand this Ohm's law. So this sentence is very, very important. So according to this, V is proportional to I, and when I remove this proportionality constant, V is equal to I into R. Okay, so R is the resistance. R is given by V by I. So this is what the actual representation diagram to relate V, I and R, where V is the voltage, which is measured as in volt. Our voltage is equal to joules per coulomb. Okay, so how much work is done by the charge is called as the voltage. Okay, so 1 volt is given by 1 joule per 1 coulomb. And I is the current, rate of flow of electrons or charge. Maybe these are all very familiar to you, but I'm recalling back all this. So current is given by the rate of change of charge with respect to time. 1 ampere equal to 1 coulomb per second. So resistance is the property of the material to prevent the current, and this is measured in ohms. This is measured in ohms. The another equation representing resistance is rho L by A, where rho is the resistivity measured in ohms meter. L is the length of the conductor, and A is the area of cross section measured in meter square. So coming to the second basic law, Kirchhoff's law. Kirchhoff's first law is KCL. So what is the statement? The summation of currents at any junction or node equal to 0. There is another way of representing the Kirchhoff's current law. The algebraic sum of current entering the node equal to the algebraic sum of current leaves the node, right? So now we have to assign a direction for a current. So that the direction of current is mentioned like this. The direction of current is mentioned like this. So current towards a node to be considered as positive. Current leaving from the node, away from the node, to be considered as a negative. Okay, so I have taken a small example. So there is a diagram given here. This is what a junction point. So this is what a junction point. Current I1, I2, I3. These three currents are entering. So we have given a plus sign here. Current I4 and I5 is leaving, so minus I4 minus I5. And according to the statement, current meeting at the junction equal to 0, and I have write this equation. Then the Kirchhoff's second law, the summation of voltages in the closed loop is 0. So you have to select a closed path, and in the closed path, the algebraic sum of voltages is equal to 0. And this is another way of representing the Kirchhoff's voltage law. Sum of potential rise and potential drop in a closed circuit is 0. Now, how will you determine whether it is a closed voltage rise and voltage drop, right? So I have taken a small circuit where E is the applied voltage, R1, R2, R3 are the resistors, and we have to consider a sine convention for the passive element. Passive element means this for R1, R2 and R3, right? So current entering is positive, leaving is negative. I have taken current in the clockwise direction. So plus here, minus here, plus here, minus here. Okay. Now according to Ohm's law, voltage across R1 is given by current multiplied by resistance. So VR1 is I into R1, VR2 is I into R2, and VR3 is I into R3. These are the voltages developed across the resistor. Okay. And we have to assume always a positive direction of current. Always assume positive direction of current in the clockwise. So the positive direction of current is always clockwise, and fix the polarity of the voltage accordingly. Okay. And if you are moving from minus to plus, it is called as a potential rise. That is, you are climbing from the ground to the first floor in your staircase. And if you are moving from plus to minus, it is called as a potential drop. So going down in the stair is to be visualized as the potential drop. So coming back to the figure, so this is my assumed direction of current. For E, I am moving from minus to plus. So this is assigned with the positive sign. And for R1, VR1 is the voltage. And I am moving from, again, my plus to minus. So it is a potential drop. VR2 plus to minus potential drop. VR3 plus to minus potential drop. So if I write the equation, KVL equation, now this is what the equation representing my circuit. So E minus VR1 minus VR2 minus VR3 equal to 0. So in a closed circuit or in a closed path, algebraic sum of potential rise and potential drop equal to 0. Okay. And if I take I outside, my equation reduces like this. E is equal to I into R1 plus R2 plus R3. And from this, my I is equal to E divided by R1 plus R2 plus R3. Now, what is my VR1? VR1 is I into R1. Okay. And when I substitute I is equal to E by R1 plus R2 plus R3, so my VR1 comes as E multiplied by R1. This R1 plus R2 plus R3, I can write it as a summation of R.